Okay, now that you're at home doing your homework, you notice that I wasn't at school today. It's because I was sick. But the nice thing about this setup is I can do the lesson even though I'm at home. So the lesson that's tonight's homework that we'll be talking about tomorrow is on rational exponents. So when we talk about rational numbers, we're talking about numbers that are fractions. So any rational number is a number that can be written as, say, a over b. So when we talk about today, we're focusing on exponents that are fractions. And so we're going to begin by looking at what that means. So let's look at this. We're going to simplify this expression here. And notice each of these has a rational exponent. It has an exponent of a half. So if I simplify this using some of our known rules already, the bases are the same. So, and I'm multiplying those two powers so I can add those exponents. So when I do add the exponents, I get an exponent of 1, which is just 16. So what this means is I've got something times itself gives 16. So I got 16 to the power of a half times 16 to the power of a half. That's 16. Let's look down here at this expression here. If I've got the square root of 16, we know we can square the root of that. We get 4. And again, 4. And if I multiply 4 by 4, I get 16. So down here, I've got something times itself gives 16. These two answers are the same, which is meaning that these two expressions are the same. So 16 to the power of a half is the exact same as the square root of 16. We've dealt a lot with square roots, but we've never seen it written as a power of a half. But that's what it is. The square root of 16 is really 16 to the power of a half. So in general, we have that. Now this can be true for any value in the square root, any base. When you think about like 25 to the power of a half, that's the square root of 25 times 25 to the power of a half. That just 5 times 5 is 25. So this means the square root of 25. So in general, if I had a to the power of 1 over 2, a to the power of a half is exactly the same as the square root of a. The things that we put in boxes here, you might want to jot down in your notes. As when we do examples tomorrow, we'll go over, well, I'll assume that we've got these kind of main ideas, these rules down. So that's what a power of a half is. It's just the square root. Let's look at this one. Say I have now 27 to the power of a third times 27 to the power of a third times 27 to the power of a third. Again, using our product rule, which is when you're multiplying powers of the same base, you can add the exponents. You add a third and a third and a third, you get 1. So this is, again, just 27. And you're taking something times something times something to get back that 27. Looking over here at this expression, this says the cubed root of 27. The cubed root of 27 is 3. 3 times 3 times 3. Because that's what the cubed root means. What times what is the base in there, which is 27. And then therefore that's 3. And this is 3. Evaluating that, we got 3 times 3 times 3, which is 27. So again, like on the last slide, we have the cubed root of 27 is really the same as 27 to the power of a third. And this is going to be true for any value of base in there. So again, in our conclusions, we can say that, say a, any base a to the power of 1/3 is equal to the cubed root of that a. And we could keep going. We could keep going with the 4th root or the 5th root and using that same property. So in general, even more general, we've got, say, if I have any base a to the power of 1 over n, so if that exponent is a fraction, then this is the nth root of the a. This is how we're going to represent rational exponents. We call this the exponent form, and we call this the radical form, the radical for the root sign. Let's do some examples. Okay, so we want to evaluate or simplify is usually our main rule. So remember the difference between evaluate and simplify. Simplify usually just means make it look smaller, make it look prettier. Evaluate means get a number. So how we evaluate, it's easier to think of doing calculations with the root symbols because our calculator uses a root symbol. We've already had experience with root symbols. So when we evaluate, we'll convert all of the exponent form into the radical form. So this is 27 to the power of a half. Remember that using that first rule, that's just the square root of 25. We can square root 25, we know that, it's 5. So 25 to the power of a half is 5. Over here, we've got the cubed root. That's how we say that. That's the negative 8 to the power of a third, but that's really the cubed root of negative 8. And so now at this point we say, well, what times what is negative 8? You can use your calculator to do some of these, but with experience, 2 times 2 times 2 is 8, but negative 2 times negative 2 is positive 4. Times that again by a negative 2, you get negative 8. So negative 2 must be the cubed root of negative 8. Over here, so we're now extending it, we're using that nth root. So how we rewrite this as a radical is this is the fourth root of 81. And how we're writing these is notice that we've got the root down here in the denominator is what goes in the little pocket of the root symbol. Same with the 3. The square root, we don't technically you could put a 2 in here, but we don't usually write it because the square root is the most common. It saves a little time, and it's a commonly accepted rule to not write 2. So back to this one, we have the fourth root of 81. What times what times what times what is 81? And that's 3. 3 times 3 is 9. Do that again, you get 81. So we've just evaluated these 3. And we've got this rule back down here that remember that in general that if I have a base b to the power of 1 over n, this is the nth root of that base. Let's look at one more example before you watch the next video. Sometimes we have an expression like this where we have a power on a power. So this one's 81 to the power of a quarter, and then that's all raised up to the power of 3. So if I go back to using some of our previous rules, then this could be using the power of power root. I'd multiply these exponents together to simplify this if we didn't see today's lesson. And when I multiply fractions, I multiply the numerators and I multiply the denominators. So one way to write this would be 81 to the power of 3 over 4. So notice now this 81 has a rational exponent where that top number is not a 1. It's 3 over 4. But it is written this way, but it can also be written this way. We could also write this using the radical rule that we've just developed, that this is really the fourth root of 81, and then keeping that it's really cubed, all cubed. So this gives us 2 ways to write this expression. It could be 81 to the power of 3 quarters, or it can be also the fourth root of 81, to all to the power of 3. This is the exponent form, this is the radical form. And this is true in general. In general, we could rewrite this as b to the power of 1 over n, all to the power of m. So going backwards, notice we're just going backwards in the power of power rule. Or this is the nth root of the b, all to the power of m. So radical form, exponent form.